Hello everyone, this will be a video for this problem in proportionality, how to solve a proportionality based problems, right? Let's go through the statement and the diagram and then we'll go and answer the question after, right? Here, what are we given? We are given that in the diagram we have EF being parallel to BC. This is parallel to this, right? And we are told that the ratio of AE, there's AE, to EB, it's 2 is to 1, right? That means that this portion is 2 times this portion, right? That's just the ratio. It does not mean that this is 2 meters or 2. It just tells you that the proportion, when we compare the length, is just the ratio. There will be 2 is to 1, right? And then they say that the length of AC is equal to 150 millimeters. So AC, this entire length here, it's 150 millimeters. So we are given the actual length for this side. You see, this side we are given ratios, but this side we are given the length, right? That's the first thing that you need to do when you go through these things. And then the question says, determine the length of AF. The length for AF, right? So when I redraw the triangle there, what were we told? The ratio of AE to EB is 2 is to 1. Remember, for the ratios, put an alphabet, right? You put either L or K. It does not matter. It does not matter, but don't put the alphabet that has M because it will confuse you with this millimeters, right? So put K or L just to show that we are dealing with ratios and not the actual length, right? So for 2, we are going to write 2K. For AE, we are going to write 2K, and for EB, we are going to write 1K according to the ratio given to us, right? And then from there, we are going to write that AC is 150 millimeters. That's what we are given, right? And remember, EF is parallel to BC, right? The first thing that you could, that's the first thing that you do, redraw the diagram and fill in the information there, right? And then write down your 3 ratios, right? Your 3 ratios. Which ones are those? When we look at this one, we have AE all over EB, right? For this side, we used top all over bottom, right? We're moving away from A because we are saying AE is all over EB. So this side, we are also going to move away from A. What are we going to have? AF all over FC, right? So AE all over EB must be equal to AF all over FC, right? And there's the first ratio. That's where it comes from, right? Top all over bottom is equal to top all over bottom for this side, for the sides, right? That's the first ratio. The second ratio, we have what? AE all over AB. So that's AE, the top part all over the whole part, right? We are going to do the same thing for this side. We have the top, which is AF all over the whole side, which is AC, right? That's the second ratio. And the third ratio, what are we going to have? We have bottom all over the whole side. This side, we are also going to do the very same thing, bottom all over the whole side. And remember, when we are writing these sides, we are moving, this side we are moving away from A towards B. So this side we are going to move away from A towards C, right? So what are we going to write for the third one? We are going to write AB. Cannot be BE because remember, we're moving in that direction, right? So it's going to be EB all over AB, right? This side is going to be FC all over AC, right? That's how we are moving. So that's how you must first write your 3 ratios, right? And whenever you are writing those 3 ratios, make sure each and every side appears twice, right? Let's look at this one. We have AE, right? AE appears here and it also appears on the second ratio, but we don't have AE here, right? And let's look at EB. There's EB, it appears here. Does it appear here? No, it does not, but it appears here, right? And then when we look at AB, AB appears where? Here, and it also appears here, right? We can also do the same thing for these the sides for this side of the triangle. All of them, they must appear twice. You must have 3 ratios and each and every side must appear twice. And remember, whenever you have finished writing these 3 ratios, the reason that you're going to use, whenever you use any of the ratios, the reason that you're going to use there to write there is line parallel to one side of triangle. This line is parallel to this side of a triangle.